Good morning. We're on to lesson 5 notes. So we started talking about how to solve exponential equations. So those are equations where in your exponent you have a variable and you have to try and figure out what it is. So yesterday or Tuesday we talked about how to solve exponential equations using common bases, and that way it works really well, but sometimes you can't make a common base between the two numbers. The ones we've worked with so far were all set up so that they worked out perfectly using common bases. But other questions you might not be able to use common bases. So we covered this one last day. Today we're going to talk about solving by graphing. You can use your calculator to also solve these, and I'm going to show you that today. And then, like I said, you can also solve exponential equations using logarithms, but we won't get into that until next unit. The first page here is just an all-area review on common bases, so you can look over that on your own. And we'll get into the second method where we can solve exponential equations graphically. Like I said, not all exponential equations can be expressed in terms of a common base, so you need a different way to solve these ones. So let's look at this equation. 3 to the x plus 2 equals 5 to the 2x minus 3. So obviously we can't use common bases here. So one way we could do it is using trial and error, just typing in different values for x and seeing if it works, but that can take a very, very long time. So we can now use a graphing calculator to determine the solution to the nearest tenth. So what we're going to do is we're going to graph the left-hand side of the equation. So the left-hand side of the equation is here. So in our calculator, under y1, I'll show you that in a minute, we're going to type in 3 to the x plus 2. And we're going to graph it. Okay, so let's type that in for our y1 and graph it onto our graph here. So I'm going to go into y equals, and we're going to type in 3 to the exponent x plus 2. And be careful, like I said, with newer calculators, you could type it in this way, but if you have an older version, you might need to include brackets around your x plus 2 like that in order to graph it properly. So try it out and make sure it matches mine, whichever way you do it. Then we're going to graph it. I better erase this part here. Okay, and then you can use your table of values. And remember, everything I'm typing shows up down here. If I press it too quick and you don't know what's happening, you can always look there to see what buttons I pushed. So now we're going to go to our table of values, second table, and now you have your table of values so we can graph it on our graph. So we're going to go back here and graph it. So starting with this one. Is just go to 50, and 4 goes off. So I have a general idea of what my curve looks like. So now I can start to connect the dots here. And it should look a little straighter than that, but you know how I draw on here. So that's going to be my first equation, y equals 3 to the x plus 2. Now we're going to graph the other one. So the second point here, we finished the first point, we're going to do the next part, which is graph the right-hand side of the equation. So the right-hand side of the equation I'm going to put under y2. And that's going to be 5 to the 2x minus 3. So essentially I'm graphing this side in one graph, this side in the other graph. And then you can see in the equation that they're equal to each other, so then we have to look on our graphs and see where they're equal to each other. In other words, where they're going to intersect with each other. So let's draw the next one. Again, use your calculator. You're going to type it into your calculator under y2. And we're going to type in 5 to the 2x minus 3. Again, you might need to put that part of the exponent in brackets depending on your calculator. Then we're going to graph that one. Use my table of values. Now my y2 is these red numbers here. So now I know at point 2 it's at 5 and etc. and I can graph that on here. Okay, so it's going to look something like this, and then it's going to shoot up. And that's my graph of y equals 5 to the 2x minus 3. Okay, so like we said, here's our equation up here. We graphed one side, we graphed the other side, and we want to see where they're equal. So looking at this diagram here, you can see they're equal here, where they intersect. That's where the two graphs will equal each other. So you can use your calculator to find the point of intersection. So onto your calculator, you're going to go into your calc menu, and then there's an intersect button, the fifth one down. Before you do, you have to be a little bit careful though. Looking at this graph, where it actually intersects has kind of gone off my screen up here somewhere. So your calculator is likely going to time out trying to find it. So you have to make sure you change your window settings so that you can actually see where the point of intersection is. So looking at this graph, I can see I need a higher number for my y values, right? I need a bigger y value. So I'm going to go into my table of values here under my window. And I want to change it so that I can see more of my y. So x min, again, it's kind of making a window here for you. Your setting is usually, and let's change it to what it is usually, this is your standard setting here. And it tells you that your x values are between -10 and 10. That's your min, that's your max. And your y values are between -10 and 10. And those are your y mins and y max. So now you can see by our graph that I need a higher y max because I can't see the point of intersection. So you'll have to play around with it a little bit. Let's say I make it 400 right now. I can just see my point of intersection now is about here. So now I can actually see it on my screen so I can use that intersect button. If you didn't know to use 400, you can use your table of values as a clue as to how high it gets or when they get really close, or you're just going to have to trial and error your window setting until you actually see where they intersect. So now that I have that, I can use that intersect button. So I'm going to go to second calc, go down to the fifth one, which is intersect, hit enter. And it's going to ask you two things. It's going to ask for your first curve and your second curve. All you really have to do is hit enter and then enter so that it knows what two curves you're dealing with. And then for your guess, you do have to move it as close as you can to the intersection. If you don't, it could time out and it'll give you an error message if you haven't gone close enough with your guess. So I'm going to hit enter here. And then it tells me my point of intersection. It tells me my x value and it tells me my y value for my point of intersection. So now I can write that down. My point of intersection was 3.315, bunch of decimals, 342.920, more decimals, and then your x value in your point of intersection is your solution. So if I round it to the nearest 10, my x will be 3.3. So now I've solved this equation. X here equals approximately 3.3, and then both sides should be equal to each other. So you can put it in to check your answers if you like. They might be off by a hair because we rounded to the nearest 10, but you should see they're awfully similar. And so that's how we solve these ones. Type each section into your calculator, see where they intersect, and then the x value of your point of intersection is your solution. So let's do just a couple more. I won't do all the ones in the notes, but let's try the first one here. So if I want to solve for x, again, common bases isn't going to work because you can't make those both into a common base. So you're going to have to use your calculator. So in my y1, I'm going to graph 2 to the x, and in my y2, I'm going to graph 5. Then I'm going to record their point of intersection. So I'm going to do a couple more in the calculator just so you can see. Again, I'm going to set my window back to its regular setting, -10, 10, 1, -10, 10, 1. That's your general setting. I'm going to change this like that. Okay, and then I'm going to go into y. And I'm going to now put my y1 is 2 to the x, and my y2 is 5. Now I'm going to graph it. Oh, I did do something here. Let's see. There we go. Okay, so from here you can see where your point of intersection is, so you don't have to change your window settings at all. We're going to go into second calc, go all the way down to number 5, intersect, and then you hit enter, enter, and then move it right to a good guess for your intersection. Hit enter, and then we have our solution is going to be that number there. So I'm going to write out my point of intersection was 2.3215, and then the x value is always your solution, and I rounded it to the nearest tenth, so I've now solved for x. X is approximately 2.3. Okay, the other ones are all kind of self-explanatory. Let's do this one as well. So again, same idea. We can't use common bases. So you can set your y1 is equal to this, your y2 is equal to this, and let's graph it and find our point of intersection. Remember, to get that, you're going to go to calc and the 5th one down, which is called intersect. Okay, clear that off. So the first one here was 2, and then in brackets 18 to the x. And the next one is 6 to the exponent x plus 1. Don't forget, some of you might have to put brackets in. I'll just show that for now, depending on the version of your calculator. If you have an older version, you might have to type in your exponent this way. We're going to graph it. Again, I can't quite see where they intersect. It's somewhere up here, so you can either try trial and error, or you can look at your table of values and kind of see where they start to get closer together. And from here, I can see my y value is 36. It actually is on here directly. So I'm going to go to my window. My y max must be higher than 10. I'm going to make it 50. Make my scale 5. The scale is just how many ticks are counting up by, so it's easier sometimes to make that a bit bigger. Now I can see where they intersect. So you're going to go to second calc, go down to intersect, hit enter, enter, and then make a good guess of where they intersect. About there. And now we have our point of intersection, which is 136. Your x value is your solution. And that one's done. The rest are similar. You can try some of those out on your own and make sure you're getting the same values and know how to work your calculator. Let's skip to an application problem. So just like yesterday or the last day we did this, when you have word problems, you can see which method works best for you. Let's do the first one here. My general form for the equation for exponential problems is this, and let's figure out what each of those have for information. So it says lead is a radioactive nuclide if 8 grams of it decays to 6.75 grams in 5 years. That means we're starting with 8 grams. It's decaying to 6.75 grams after a total time of 5 years. It says then what is the half-life of lead? Half-life, that tells you what your B value is. My B value is a half, and it wants to know how long does it take to break down to half of what it was previously. You're looking for a P value. So now we type in everything we know. This is what we have so far. I can't use common bases here, it's a bit too complex. So to solve for an unknown exponent to figure out what P is, we can't use our method of common bases, so we're going to use graphing by now. Later on, you'll be able to use logarithms to solve this. So for our y1, we're going to type in 6.75. For our y2, we're going to type in 8 to the 0.5, 5 over p, but you're going to enter it in as an x on your calculator. And let's see what that'll look like. So bring up the calculator. You're going to go into y equals, clear out whatever you had. My y1 was 6.75. My y2 was 8, bracket 0.5 to the exponent 5 over p. Again, you may need to use brackets here if you have an older version of your calculator. Other ones will work fine without brackets, so make sure you're getting the same answer as me when you're doing it. Then we're going to graph it. And I can see here, it's going to intersect somewhere over here, but it's off my screen. So I need to have a bigger X value here. So I'm gonna go to my window, and my X max, I'm gonna have to make a bit bigger. Let's try 30. And now I can see my point of intersection. So I can go back into my calc menu, move down to intersect, hit enter, enter, and then move it over until it's a good guess for an intersection where they meet together, which will be about here. And then you have your point of intersection there, 20.398 and 6.75. So my point of intersection was 20.398, bunch of decimals, 6.75, and whatever your X value was is your solution. And we wanted it rounded to the nearest tenth, so it's going to be 20.4. And actually we called it P here, we just substituted it with an X for the calculator. And I can see my time was in years, so my P value will also be in years. And now we have a solution to that word problem where there's a variable in the exponent. That's it for today.